Okay, today's video is over angles of elevation and angle of depression. So we have two EQs. How do you use angle of elevation and depression in real world problems? And how are they similar? So first I wanted to show you this picture showing you that the angle of elevation and angle of depression are the same thing. You can see these parallel lines being cut by a transversal, giving us alternate interior angles right here. So you can see that they end up being the same thing, which is really cool. So our first question says the Seattle Space Needle cast a 76-meter shadow. So I'm going to go ahead and draw the Space Needle and draw its shadow. So this is 67 meters. The angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. So that 70 degrees is right there. And it wants to know how tall is the Space Needle, so here. So using our trig ratios, we have the opposite and adjacent side, which is going to be tangent. So tangent of 70 degrees equals x over 60. So we're going to multiply by 60 on both sides. And so I get x equals 60 times the tangent of 70 degrees. And when I plug that into my calculator, I get 164.849 meters. Okay, question number 2 is about angle of depression. So Lindsay is 9.2 meters up in a building. So 9.2, here's Lindsay. And the angle of depression from Lindsay to Pete is 79 degrees. So I'm going to go ahead and draw this down. But remember, the angle of depression is measured from the horizontal down. So the angle that's 79 degrees is right here. So in our triangle, it's going to be right down here because of the alternate interior angles. So it says find the distance from Pete to the base of the building. So this portion right here. So we have opposite and adjacent again, that is tangent. So tangent of 79 degrees is equal to 9.2 over x. So I'm going to multiply by x on both sides, and I get x times tangent of 79 equals 9.2. And then I'm going to divide by tangent of 79 on both sides, and I get x equals 9.2 divided by tangent of 79. And I'm going to plug that into my calculator, and I'm going to get 1.788 meters.